Hi everyone, this is Janine Co, aka Janine The Tutor. As you know, now is a very difficult time for each one of us, whether you're in middle school, high school, or university. Many students and families are deeply affected by the recent school closure. And as a part of OneClass, we are very fortunate that we are able to adapt quickly, and that's why we want to extend our helping hand to you students to stay on top of your studies and learn at home. So, we're offering and running free and daily classes for math and chemistry from grades 11 to first year college and university. In addition, we are giving away 100,000 hours of free private tutoring. So, if you're interested, make sure to scroll down below and book your time slot. For today's class, I will be going over geometry, so we'll go through special angle pairs and all of the examples. So before anything else, I just wanted to make sure that you guys are hearing me coming through. And also, if you can see my screen. Okay, great. So going back to this, right? So if you have special angle pairs, right? So I think the key point here is to be able to apply these terminologies as opposed to trying to remember the definition. So in that case, if you're looking at complementary angles, right? So think back about what your teacher probably discussed in the classroom. So this is when two angles, right? They sum up to 90 degrees, right? And they don't necessarily have to be adjacent to one another. So for example, if you're looking at 53 degrees, that means the other angle for them to be complementary to one another, it has to be 90 minus 53, which is 37, right? So this is 37 degrees. Okay, so yeah, so they need to sum up to 90 degrees, right? So two angles that sum up to 90 degrees. Okay, so for supplementary angles, right, that means they need to be 180 degrees as opposed to 90 degrees, right? So it's two angles that sum up to 180 degrees. Again, they don't need to be adjacent to one another. So for example, if you're looking at, let's say, let me just think about this, 95 degrees, right? For example, and the other angle, so 180 minus 95 would give you 85, right? So the other angle needs to be 85 degrees. Okay, there we go. So that's for supplementary angles. And if we're looking at vertical angles, I know that your teacher probably told you that vertical angles just means when two angles are opposite and they need to be congruent, right? But again, remember geometry is very spatial or visual. That means I like to remember things based on what I'm seeing. So for vertical angles, I like to call this the X pattern. So this is just me. Okay, so this is Janine the Tutor tip. This is your vertical angle, right? So you have the X pattern, and the reason why I'm calling this the X pattern is because anytime you have an angle, so say for example, this is 41 degrees, the opposite angle, right, over here needs to be the same, which is 41, right? So that's what the X pattern is for, right? Because it forms an X. And on top of that, you need to remember that they need to be congruent, which is the same, right? So these are opposite angles. So opposite angles that are formed by intersecting lines, right? And these angles need to be congruent, right? This is the symbol that we use whenever something is congruent. Okay, great. So for adjacent angles, right? In that case, well, as the word implies, right, what does adjacent means, right? For example, I'm sitting next to someone, right, which you shouldn't be do at this point, right, because we need to practice that social distancing. But adjacent angles just means that it's side by side, right? So the next angle, right, that means they're sharing the common vertex. They're sharing a common vertex or a common side, right? So that's what adjacent angles are. So if you're looking at, let's say, 12 degrees, right? I guess this is probably too big for a 12 degrees, but maybe we can have that here. So if this is 12 degrees and let's say this is 35 degrees, right? They don't necessarily have to add up to a certain degree as long as they share a common vertex, right? Which is like for example, vertex B, and then they share a common side, which is AB, that makes them adjacent to one another. Okay, so adjacent angles need to share a common vertex and a common side. Okay, so for linear pairs, right, this is a special case because it needs to be supplementary and at the same time it needs to be adjacent, right? So as you can see, the terminologies that I've listed, they're not really just grouped into one category. Sometimes they can overlap, right? Which we're looking at right now, which is linear pairs. So linear pairs, maybe we can use 82 degrees as an example, right? So you have a straight angle here, and it's comprising of two angles. So you have 82 degrees, right? And 180 minus 82 is equal to 98, right? So this has to be 98 degrees. Okay, so again, linear pairs, they need to be adjacent and supplementary. Okay, so that's it. So they need to be adjacent and supplementary. Okay, great. So hopefully these terminologies make sense. And again, I just want you to be able to apply them. You don't, so it really depends the way you learn, right? Again, it's all about your learning style. And if you think about it, some students, they like to remember things visually, right? So they have that, I guess, photo capture kind of memory. So like me, I would remember vertical angles as just an X pattern, right? And then I know how to apply it, right? So, and some students, on the other hand, they would just remember the definition, right? So again, here's the definition, and depending on how you learn, right, just remember those things. Okay, great. So let's proceed with a real example now. Okay, so as you can see, we have a couple of angles here, and they're all sharing this common vertex B, right? So we need to give an example, right? It says here, name an angle that is vertical to angle ABC, right? So for something to be vertical, remember what I said, it needs to be opposite and it needs to be congruent, right? Or the X pattern. So you're going to look for that X pattern over here. And you know that you're looking at ABC, right? So that means the only vertical pattern or vertical angle in that case would be EBD, right? There's no other X pattern here opposite to ABC. That's why it's only going to be EBD or DBE, depending on whatever you like to call your angle. So both are acceptable names. So it's EBD or DBE, right? However, here's my, I guess, my tip for you. So whenever you're trying to name angles, don't try to start naming from the vertex, right? Because that would be wrong. So you would actually say that it's EBD or DBE. Okay, great. So for number two, right, you would say name two angles that form a linear pair. So a linear pair, again, if you remember, it needs to be adjacent and it needs to be supplementary. So you're going to look for a straight angle. So that's EBC, right? And there's going to be multiple answers here, so don't feel that you're going to restrict yourself to one answer because whatever I'm showing you is only just one. No, because there's a couple of angles here. So again, just make sure that it corresponds to the one that they're asking for. So for the linear pair, right? So maybe we can use this, right? We have EBC, right? And if you look at EBD and DBC, they actually form a linear pair because it's adjacent, right? First of all, and they're supplementary, right? So we can go ahead and use that, right? So EBC is over here, so you can say EBD and DBC are forming a linear pair, right? And if you want to use the angle that's above that, right, above EBC, you can actually use EBA and ABC, right? It's up to you. Okay. So for number three, it says name an angle that is adjacent to angle FBE. Okay, so let's look for FBE. So FBE is right here. There's only two angles that will be adjacent to FBE, right? And that would be EBD and GBF, right? Because if you have FBE, right, it's only two, right? This angle and this angle. Again, you can call it as DBE, doesn't really matter, or you can call it as FBG. Okay, so name a pair of complementary angles, right? So what does it mean when two angles are complementary to one another? They need to be 90 degrees, right? They need to sum up as 90 degrees. So maybe we can just use this example, right? If you're looking at angle EBG, right, you know that this is 90 degrees, right? Therefore, you can say that EBF and FBG, right? So FBG is over here. So they're actually complementary because they sum up to 90 degrees, right? So there is another angle, right? Which is 90 degrees, right? So you can actually say that GBC is forming a right angle. And why is that? Well, you know that EBC is a straight angle, right? That means it's 180 minus 90 degrees, right? Therefore, GBC would also be 90 degrees, right? And you can actually say that GBA and ABC are complementary angles, right? Because they also sum up to 90 degrees, right? So just by looking at your figure, right, sometimes you need to infer the information that's presented, and it's not too obvious just by looking at it. Okay, I think I've covered everything so far. Okay, so maybe let's look at parallel lines cut by a transversal, right? So going back to the definition again. Okay, so what does it mean? First of all, before we even start with these chunk of information over here or terminologies, if we have parallel lines, right? And what does it mean when something is a transversal line, right? So if you have parallel lines, you probably know this by now, but parallel lines, they never intersect, right? So they're just two lines. However, if you have a transversal line, right? We know that a transversal is a line. Therefore, if you have something like this, okay, so this is your transversal line. So what a transversal line does, right? So this is just by definition, right? So it's cutting through two lines, right? In the same plane. So it has to be in the same plane. So if you imagine that this looks like your tabletop, right? So it's in the same plane, and at the same time, it's through two distinct points, right? Same plane, two distinct points. So that means that points will never be the same, right? Because it's distinct, right? So you have this point, and they're never the same. So two lines, right? Cutting through the same plane at two distinct points. So that's what a transversal line is, right? And then again, this is alternate, right? This is supposed to be alternate interior angles, and we have alternate exterior angles. Okay, so maybe we can cut this based on alternate and consecutive, right? So if I'm looking at alternate angles, right? So let's say I'm looking at alternate interior angles, right? And alternate exterior angles. So what does it mean when something is interior and exterior, right? So first of all, your interior angles would simply just be this, 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 and this, right? Because as the word implies, it needs to be interior. It needs to be inside your two parallel lines, right? Anything that is outside, therefore here and here, here and here, they're exterior, right? So if you have alternate interior angles, that means they need to be on two different sides, right? So in that case, okay, can you guys see this? So this little dot right here, the green dot, and this, they're actually alternate interior angles, right? This check mark and this check mark, they're alternate interior angles. So you can actually say that the little dot right there and the check mark, they're actually alternate interior angles, right? So that's what the transversal line does. Whenever it's cutting through parallel lines, it creates these So this is like 1, 2, 3, 4, 5. So it creates 5 different types of angles. And as you can see, you have your alternate interior angles from here. And then now we look at alternate exterior angles, right? So this will be in blue. So if you're looking at alternate exterior angles, right? Again, remember it has to be exterior, therefore it needs to be outside your parallel lines. Therefore, because it's alternate, right? That means this and this, right? They're alternate exterior angles, right? This over here and this over here, they're actually alternate exterior angles, right? So we can say it's the squiggly line and X, right? So those are your alternate exterior angles. And because for consecutive, right, as the word implies, consecutive means it's just side by side, right? Whatever's beside that or on the same side, right? That's what it means. Because if you think about looking for consecutive numbers, what does it mean when it's consecutive? It needs to be on this on like the next number or this, I guess the one next to it, right? So in that case, yeah, as you notice for geometry, it's pretty much whatever you like for terminologies. It's pretty much whatever you're reading, right? It actually implies the exact same thing. It's very literal, so you don't really have to think. I guess put a lot of thought about the terminologies. Does that make sense? So whatever you're reading, so let's say it's alternate, that means it cannot be on the same side, right? It has to be on the opposite side. And if it's interior, right, that means it's inside. So it's very oh my gosh, literal, right? In the sense that you don't really need to kind of what do you call this? Think about the terminologies too much, right? Because whatever is there, that's what it means. Okay, great. So again, we're just drawing the parallel lines and you have the transversal, right? Great. Consecutive interior angles. Okay, so interior angles, remember, it's basically this over here, right? That's what the interior angles look like. So it's this, right? However, because you're looking at consecutive interior angles, they need to be on the same side, right? So you have this and this, right? Okay, maybe we can pick another color. So let's pick this. Okay, so we have, okay, let me just think about the shapes. Okay, if we have this over here, okay, so let me just draw this. So this and this, right? These are actually consecutive interior angles, right? Because they're inside and at the same time they're on the same side, right? So when I say on the same side, it's on the same side of the transversal, right? So when you cut through the transversal, that means on the left, right? That's your consecutive interior angles. Okay. And then on the other hand, if you're looking at this, see, I'm running out of shapes now or legends. Okay, let me just think about, okay, maybe we can write C. Okay, C and C over here, right? So these two, right, because they're on the same side of the transversal, which is the right hand side of the transversal, that means they're consecutive interior angles, right? So that's why we're referring it as interior, right? Because it's within that parallel line, and at the same time it's consecutive because it's on the same side of the transversal. So that's just what it means. This is just what I like to tell my students. Anytime you're learning math or even science, it's just easier for you to kind of remember things based on your, I guess, your learning style, because at the end of the day, you want to be able to remember this even after you graduate, right? Because that's what true learning is. It's not like you learn something and then after, like, let's say sophomore year, you just forget about this thing, right? So, okay, great. Yeah, so if you're looking at consecutive exterior angles, that means it has to be outside your parallel lines and at the same time it needs to be side by side, right? So we can probably say that this over here, let's put a square. So this and this, right? These are consecutive exterior angles, right? And then on the other hand, right, maybe we can have, okay, J, because that's what my name stands for. So you have this over here. These are consecutive exterior angles, right? Because they're on the same side and they're outside your parallel line. Okay, great. So once we finish that, right, maybe we can move on to corresponding angles. Okay, corresponding angles. So corresponding angles, right? That means, okay, let me just finish this if we covered everything. So we covered alternate interior angles, exterior, consecutive, interior, and exterior. Okay, great. Before we get into corresponding angles, I just wanted to make sure you guys understand what it means when it's alternate interior angles, exterior, right? And what happens to their angles, right? So say, for example, this is, okay, let's try 89 degrees, right? So this little green dot is 89 degrees, right? So in that case, if this is 89 degrees over here, that means this and this needs to be exactly the same thing, right? So that's one of the key, I guess, features of having alternate interior angles is when you have this Z pattern. Can you see this? Okay, let me just find a highlighter and then we can just go over that. Okay, so it's basically this. Okay, great. Because we want everything to be straight. There we go. Can you see this gray thing over here? So alternate interior angles really form that Z pattern, as I like to call it, right? So depending on which one you're looking, so it could be this over here or it could be this, right? So remember that Z pattern. Okay, so you know that if you're looking for a Z pattern, that means this angle over here and this angle, they're going to be the exact same thing. They're congruent, right? So alternate interior angles are congruent. However, if you're looking at alternate exterior angles, although it's pretty much very far apart, right? That means they're still going to be congruent, right? So anytime you hear the word alternate, it needs to be congruent. So maybe we can write that. Okay, so these two, they're congruent, right? So even though you have this blue thing over here and this over here, they're actually congruent still. Okay, so let's move on to consecutive. Interior angles and exterior angles. Okay, so as I mentioned, right? Actually, before we get into that, let me clear this. Okay, so first of all, if you have corresponding angles, right? So remember, yeah, before we get into consecutive interior angles and consecutive exterior angles, I just wanted to quickly kind of talk about corresponding angles. So if you're looking at this part right here, right? So corresponding basically means they're on the same position, right? Or in the same position. So if you're looking at the C over here, that means they're corresponding to one another. Does that make sense? And then if it's corresponding interior angles, that means it would be this over here and this, right? Does that make sense? And then on the other hand, if something is consecutive underneath that, so this part is consecutive to this, right? And it's still interior angles. Okay, so corresponding would be this and the C one. And then if we have this over here, this is consecutive, right? So it's just this and the double one. So this one is the same as this one. Okay, so those are your consecutive interior angles, right? So consecutive interior angles and consecutive exterior angles, they just are supplementary angles. So supplementary angles, they're not congruent, right? Because remember, it's basically on the same side of your parallel line, right? So if this one is, let's say, 89 degrees, that means this needs to be 180 minus 89 degrees, right? And then for corresponding angles, because they're on the same side, you have what you call an F pattern, right? Okay, let me find. Okay, can you guys see this? So this is the green one. If you guys can see this, basically, actually no, hold on. Here and Okay, we need to draw another one because I think this is confusing if we have so much variables inside. Okay, so we talked about consecutive exterior angles and interior angles, right? Maybe we can split the corresponding angles into a different one. Okay, so again, consecutive interior angles are basically this. They're supplementary angles, and consecutive exterior angles, you have this, and they're supplementary, right? Because they form a straight angle. Okay, so let's proceed to corresponding angles. Let's just draw another one, because I think it just gets very confusing. Okay, there we go. And this is the purple one. Okay, so for corresponding angles, right? Okay, here's the thing with corresponding angles. It could be interior and it could be a mix of exterior, right? So earlier we said that this over here and let's say this, right? They're still considered corresponding because they're on the same side, right? However, right, what if one of them is actually exterior, right? So if one of them is exterior, right, so say for example somewhere here, that means they're still going to be corresponding because if you think about the transversal line, it's still going to be on the other side, and it's only on one side of the transversal, which is the right hand side, right? So that's what it means when something is corresponding. It needs to be only on one position of your transversal line. So it could be this, it could be over here, right? It doesn't really matter as long as you make sure that it's on the same position of your transversal line. So it could be on the left as well. Okay, great. So we've covered corresponding angles, and yeah, and also just keep in mind that whenever I'm talking about this point, right, it could also be this point, right, and this point. So yeah, that's what it means when it's corresponding. So I think it gets a little bit confusing because you can have a mix of interior and exterior. It's not just interior angles the majority of the time. And that's why I had to illustrate that on a different parallel line cut by a transversal. Okay, great. So if we solve for x, right, and we need to solve for the missing angles. Great, so we have x and 3x minus 120. Okay, so if you kind of rotated this, right, because we're not used to seeing two parallel lines that are drawn vertically. Okay, so maybe kind of flip this and flip this into something like this, right? And then you have a transversal line. So this is your transversal line. And then if you're looking at your transversal line, you're seeing that this is x and this is 3x minus 120, right, degrees. And this is x degrees, right? So remember for your terminologies, right? Basically, you're looking at exterior, right? And why is it exterior? Because it's outside your parallel lines. And on top of that, right, that means it's going to be alternate, right? So what does it mean when something is alternate? So just keep that in mind. If it's alternate, it has to be congruent. And if it's consecutive, right, it has to be supplementary. So if it's alternate, that means you can say 3x minus 120 degrees is equal to x degrees. And then all you have to do is solve for x. So you have 3x minus x, that would be 2x, and that's equal to 120 degrees. Dividing both sides with 2, you get 60 for your x. Okay, and because we need to solve for the missing angles, right? So this is 60, therefore this also needs to be 60 degrees, right? Because if you have 3 times 60, right, that's 180 minus 120, that's 60. Okay, great. So this is what you call your alternate exterior. So let me just abbreviate that, exterior angles. Okay, so now that we have that completed, right? So maybe we can move on to this. So if we have x plus 50 and we have this, right? So again, this is not really part of what we covered so far. So what they're trying to tell us is basically you have some angle that is exterior and some angle that is interior, right? But we don't really have a specific rule, right, or specific terminology where we can actually deduce information from. So in that case, if this is x plus 50, right, the only thing that's going to, I guess, we are able to use in this matter is if you're trying to kind of use this as a 180 degrees and you're looking for this, right? And then you can probably say that this is corresponding to this and therefore they're going to be the same angle. Okay, so if something is corresponding, right, that means they need to be congruent, right? So let's not forget about that. So they need to be congruent and they need to be in the same position. Okay, so the reason why I cannot use alternate exterior angles or interior angles and consecutive interior or exterior angles is because I don't have anything that's exterior and I don't have anything that are both interior. Does that make sense? So that's why I'm using x plus 50 and I'm subtracting that, right? With, actually, you can say that this is x plus 50 as well, right? So there's a lot of ways to look at this. It doesn't necessarily have to be 180 minus x plus 50. You can actually say because they're corresponding, right? They're on the same side of the transversal. You have x plus 50 here and you have x plus 50 here, right? So what you can say from this point on, you can say x plus 50, right, plus x minus 10 degrees is equal to 180 degrees, right? And why? Because they're both interior angles, right? And they're consecutive, right? They're consecutive interior angles, right? So that's why you can actually say that this is 180 degrees, right? They're supplementary. So you would have 2x, and this is basically plus 40, and this is equal to 180, right? Okay, great. So this is 2x, and then you would have 180 minus 40, so that would be 140, right? Divided by 2, you would get x is equal to 70, right? So that means x is 70. So if you're looking for this angle, you need to add 70 plus 50, so that's going to be 120. And then on the other hand, you have 60, right? Okay, and just to check, right, if you know that this is 120 plus 60, that would be 180. Okay, great. So moving on to this example. So as you can see, we have exterior angles, right? And at the same time, they're alternate, right? So alternate exterior angles. Okay, so because these two are alternate exterior angles, right? You can actually say that this is 2x minus 20. And they're congruent, right? So you can actually say that this is equal to x plus 26, right? So 2x and you have x here, that would give you x, and moving 20 to the opposite side would give you 46, right? Yeah. Okay, so that's 46. So we can actually say that this is 46, right, plus 26. That would give you 72 degrees. And this is going to be 2 times 46 minus 20. So this is equal to 72 degrees. And because remember, they're alternate interior angles, they're supposed to be congruent. So that's why they're both 72 degrees. Okay, so for this one, right, so remember, we're not really used to seeing parallel lines that are drawn vertically. So that means if we kind of rotate this, I guess 90 degrees, right, clockwise, you're going to see that you have a parallel line and then you have a transversal. And the transversal creates that 90-degree angle. Okay, so so basically over there you have 90 degrees on this side and you have 2x minus 80, right? So because they're alternate, right, alternate exterior angles, that means they're equal to one another. Therefore, you can actually say that 2x minus 80 is equal to 90, right? And you can actually find what x is. So you have 2x and you have 170, right? Divided by 2. Yeah, 90 plus 80 is 170. Divided by 2, it's 85. So in that case, because you're just looking for this would just be 90 degrees. Sorry, this is 90 degrees in total, right? But if you were to solve for this whole thing, plug in x, you would have 2 times 85, right? And this is minus 80, so this is 90. Yeah, you don't even have to plug in x because you know that if this is 90, it has to be congruent, right? So therefore, this has to be 90 degrees as well. Okay, so in this example, because they're consecutive, right, that means they're on the same side of your parallel line. And on top of that, you know that they're supplementary to one another. So you can actually say that this is x plus 20 plus x minus 15, which is equal to 180 degrees, right? And first of all, these are what you call consecutive interior angles, right? Okay, so you have 2x, and this is 20 minus 15, so that's 5. And that would be, yeah, 20 minus 15, so that's 5. And then that's going to be 180 minus 5, so that would give you 175, right? So that's 175 divided by 2. So 175 divided by 2 is 87.5, right? So once you have 87.5, that means all you have to do is plug in 87.5. So 87.5 plus 20, that would give you 107.5 degrees over here. And because you know that this is going to be 180 minus 107.5, that would give you that angle. But because we're solving for this angle and all we have to do is plug in x, so we would have 87.5 minus 15, and that's equal to 72.5 degrees, right? So when you add the two, right, 72.5 plus 107.5, you should get 180 degrees, right? Because consecutive interior angles, they need to sum up to 180 degrees because they're supplementary. Okay, so maybe we can end this class on this example, right? Because I know this class is supposed to be until 3. So over here, right, again, this is not really one of the terminologies we've discussed so far, right? So that means you need to, it's supposed to be your intuition that you're saying that if this is x plus 96 degrees, therefore this needs to be x plus 96 degrees as well, right? And then all you do is make sure that they add up to 180 degrees because this is consecutive interior angles, right? So x plus 96 degrees, and this is plus 3x minus 92. This is equal to 180, right? Because they're supposed to be supplementary. So consecutive interior angles. Great. So once we have x and 3x, that would give us 4x. And then you have 96 minus 92. That would give you 4, right? And you would have 180 minus 4. That would give you 176. So dividing both sides with 4, you should get 44, right? X is equal to 44. And therefore, when you plug in 44 over here, so 44 plus 96, that would give you 140, right? And because you know that this is 140 degrees, you can say that this is 180 minus 140, right? Or you can plug in 44 times 3 minus 92, that's equal to 40 degrees, right? And it's actually true, right? If you have 140 plus 40, that's going to be 180 degrees. Okay, great. So I think so far we finished the majority of the angle questions, right? And for next class, we'll just go over parallelograms because we did kites and also trapezoids, right? So we'll go over parallelograms in a bit. So yeah, thank you so much guys for tuning in. And if you do know any of your friends who might benefit from this, please just ask them to join, right? I think it's just more fun to be able to study together and stay on top of things. And if you're interested in, attending one of my, actually more of my classes, right? Not just one, hopefully. You can find my schedule here. So this is oneclass.com/livestream. So yeah, if you're interested to see my daily schedule in terms of the times of my classes, because I do teach not just geometry, I do teach other classes as well. And also, along with other talented educators, they also are teaching on this platform. So I really appreciate that if you would check out our schedule. And without further ado, I'll see you on my next class. Bye, guys.